multi-step equations today. You guys have done the 1 and 2 steps, but now you're going to upgrade. All right. And there's something that we use in Algebra 1 down here to help you remember all of the steps. All right. And it's an honest request as well, you know. So it stands, I'm going to write these letters out, and you're going to need 2 lines for each of them. Okay, and what it stands for is don't call me after midnight. These are the steps for you to solve multi-step equations, whether you have variables on the same side or both sides. So, we are going to tell you what each of these mean now. Don't is for distribute. You have to distribute anything if there is any. Then you're going to combine like terms. Move the variable. And I typically recommend you move the lighter variable, but very rarely you're going to move the other variable. Then you do add or subtract, and multiply or divide. So pretty much it's what we talked about yesterday with SATMAP, but a very much more sophisticated and upgraded version. Now, there's a big note to this. Sometimes, okay, you won't always use all of the steps. So go in the same order, regardless. And I'll show you what I'm talking about right here. So our first problem that we're going to do right here is example 1. And we're going to start off easy. It's going to be 3x minus 4 plus 2x equals 36. Now, we did a problem like this the other day with our 1 and 2 step equations. And all you need to do is go and don't call me after midnight order. So what I'm going to do, and it's something I recommend you do, I say don't call me after midnight. And I go through each of the steps. Right here, well, there's no distribution, so check. I don't need to do it. Then you've got combining like terms. Now this one, it does have terms that we can combine. And remember, we're only looking at each side of the equal. So the 3x, I can put a box around it. And the 2x, I can also put a box around it because they have both the same variable and the same exponent on those. Which leaves us with the minus 4. Remember, I cannot circle the 36. It's on the other side of the equal sign. We only combine like terms on the same side. So I'm going to go ahead and rewrite it, and it's going to become 3x, plus 2x, which is 5x. See, those right there. And then it's going to be minus 4. The other stuff comes down because we didn't do anything to the other side. That easy. Next, you're going to move the lighter variable, but you only have the variable once, and you've got it down to a 2-step so you can skip the step. And now you're going to either add or subtract. In our case, we're going to go ahead and end up adding 4 to each side since it's the inverse operation. And it's going to zero out. And we are now left with 5x equals 40. Divide. This is multiply or divide, so we're going to divide by 5 since it's the opposite of multiplying. When you have 5x, it's saying 5 times x. So we're trying to cancel it out. What we mean by canceling it out is we're going to end up 1ing out. So now you're going to get x equals 40 divided by 5, which is 8. And that's how you would do it. You still use don't call me after midnight. And anytime we solve equations, I'm going to tell you, hey, don't call me after midnight. So get used to it. This is super important right here. All right. We are going to do example 2. It's going to be a little bit different. And this time it's going to be 12x plus 9 minus 3x plus 5 equals negative 49. So let's write it out. Don't call me after midnight. All right. Is there any distribution? No. So we're going to say next. But you do have a lot of like terms that you can combine, especially on the left-hand side. So we are going to go ahead and take I'm going to put a box around anything with a variable. And you get 12x minus 3x, which is going to get you a 9x. And I'm putting a circle around all of these constants. So it's going to be positive 9 and positive 5, which is going to get you a positive 14. And it's going to end up equaling negative 49. And now we're down to a 2-step. So I'm going to have you continue this problem and then type in your answer. Now that you've typed in your answer, I'm going to show you my work. Oops. We didn't have to move the variable. All we had to do was do the inverse operation to both sides. All right, so this zeroed out and we got 9x equals negative 63. We divided both sides by 9. This 1'd out and you got x equals negative 7. And there you have it. So I hope you got negative 7. If you messed up on the sign, make sure that you remember that triangle that we talked about the other day. Use it. Have it help you. I don't just do things for kicks and giggles. Okay, I promise. There is a method to my crazy. So now we're going to go ahead and level up. We are going to be using both of these pages for our multi-step equations, which is why on your table of contents it says multi-step equations for 7 through 8. All right, so here is example 3. And this is one that I'm going to be introducing distribution to y'all. So same thing. Don't call me after midnight. So first thing it says is you need to distribute. In this case, we're going to be distributing this 5 right here to the x, which is going to get us 5 times x and 5x, and then 5 times negative 2, which is going to get you a negative 10. We didn't touch anything else because that didn't have any distribution with it, so we bring everything on down. It just drops down. Now our next step is what we've been doing. It looks like problem 1 did now. And so we're going to combine our like terms. Put a box, and if you don't want to use the box, you're like, I can do it without the box, Miss Samji. Good. That's awesome. Do it. I am going to show my steps just so you guys have them. So 3x plus 5x gets you 8x. Minus 10, because nothing happened there, and equals 14. Notice how I'm going line by line by line to show my work. This is what I expect from you as well. You're going to see it like that on your STAR tests, on your SATs and everything, when they ask you to analyze somebody's stuff. So now we do our usual. In this case, same thing here. There's no variable to move to the other side right now. We're not there yet, all right? So I'm just going to put a check there. We will get one next. All right, so I want you to go ahead and solve this for x, and I'm going to have you put your answer in. All right, now that you guys have gone ahead and put in your answer, I'm showing you how I'm zeroing things out and what I did to solve my problem. Remember, I asked that you box your final answer so that it sticks out. It helps your brain keep it neat. All right, now here it is. These are going to be variables. Oops. These are going to be equations with variables on both sides. All right, so I am going to start off with example 4 here. Okay, so this one's a long one, and so I'm going to start it actually a little bit over. I know, we're cheating a little bit, but we're going to take advantage of the space that we need and the space that we have. I'm sorry, I'm having the epic struggles in that I can't count, and I keep writing the same number down. Whew. Guys, we got this, even if Miss Lamji is having the super struggles. So your problem is 13x minus 5 equals 10x plus 37 minus 4x. All right, and we're going to write out our steps. Don't call me after midnight for distribute. In this case, there is no distribution, so we're going to put a check and keep moving forward. Combine like terms. You want to do it on each side. So oops. If I were to cover up this side right here, there are no like terms here. So we're okay on that side. But now, when we look at this side and ignore this side, you'll notice we have these two in common. So let's combine our like terms. We're going to bring this side down. All right, and what I'm going to do is I'm going to box and circle. Remember, you do not have to do this if you're okay without it. Just make sure you watch your signs. 10x minus 4x is going to get you 6x, and the plus 37 just comes on down. Now, this is where it takes place. Now, you don't necessarily have to move the lighter variable, but you do have to move one of them. You want to get your variables on one side and your constants on the other. So here's what we're going to write down really quickly just so we know it. These are hashtag goals, kind of like relationship goals. I know, I'm kind of dating myself maybe. It's okay. Your goals are that variables are on one side, constants on the other. So we have to move the variable. Now I want you to think about it this way. And if you were in my class, I'd be pointing to a bookshelf that's loaded with books. And guess what? I want to move it to the opposite side of the room. Now, if I want to move it to the opposite side of the room, Would I unload all of the books and then move the bookshelf, or just pick it up and have a very Hulk moment and move it to the opposite side? Now, I don't know about y'all, but I'm getting old. Okay, I am not picking up that entire bookshelf all at the same time. I want to pick the lighter of the two variables, just because it gets easier that way. And for the most part, that's what you're going to do. It's okay if you don't do it. You'll just work with a couple more negatives. So I'm going to do the opposite action. And because this 6x right here was a positive, I'm going to do the opposite by subtracting it. I want it to zero out. So 6x minus 6x zeroes out. And 13x minus 6x becomes 7x. We didn't do anything to the constants, and we're just going to bring them on down. And this one right here, actually, well, you know, it's getting all lonely by itself right here. It's going to scooch on over. And now you're going to do add or subtract. So plus 5, because that's your inverse, zeroes out. And now you have 7x is equal to 42. Do the opposite of multiplication and divide both sides by 7. This one's out. X is equal to 6. Guys, you're almost there. So now I'm going to give you a mega don't call me after midnight problem. Are you guys ready? All right. We're going to need all of the space possible for this one. You ready? I'm even going to make my pen a little bit smaller so I can fit all of it in. So it's going to be negative 7 times x minus 1 equals negative 5 times x minus 5. Oh, no. Oops. Sorry, guys. Had to do some surgery. Minus 4x. All right, so that's a big old problem right there, right? And I'm going to draw this box here so you guys can see that's separate. Let's write out our don't call me after midnight. I told you this one was a whammy. But we're going to do it together and we're going to follow our steps. And if you don't call me after midnight, you can make sure you solve this problem. So here's our first step. We have to do distribution. And check this out. This has distribution on both sides. We got this. So negative 7 times x is negative 7x. Negative 7 times negative 1 is going to get you a positive 7. And you'll notice I'm going to be shifting over my equal sign just so we have a little bit more room to work with. All right, then on the opposite side, we've got negative 5 being distributed to everything inside the parentheses. And you've got negative 5 times x, and then negative 5 times negative 5, which is a positive 25. And you still got that negative 4x, but we didn't do anything to it because it's outside of the parentheses. We're just going to bring it down. Kind of bums along like a third wheel sometimes. It's okay. Now you're going to do combining like terms. And I'm going to go ahead and draw my little railroad here. On this side right here, there are no like terms to combine. So we lucked out there. And I'm just going to bring it on down. But on this side right here, you'll notice we've got negative 5x and negative 4x that are going to combine. So I'm going to write negative 9x. The 25 had nothing to combine with, so it just drops on down. All right, now we got to move our lighter variable. This is where it gets tricky. You have to remember for negatives, of the two that's smaller, it would be negative 9 that's smaller than negative 7. So we're going to do the opposite and move the 9x over to the opposite side. You do the opposite action when you move it to the opposite side of an equal sign. Negative 7 plus 9 is going to get you 2x. This side right here, it zeroes out. Everything else just drops on down because we have not touched it. And now you have it down to a magnificent two-step. So let's move through this, and we're going to speed. We're going to subtract 7 because it's the inverse. Do it to both sides. This zeroes out. You're going to get 2x equals 18. Divide by 2 because it's the opposite of the multiplication on both sides. 2 divided by 2, 1's out. And then x is going to equal 18 divided by 2, which is 9. And there you have it. You have solved multi-step equations. These 2 pages right here, this is what's going to keep you surviving in Algebra 1. Now, there is one more thing